Math 3 Lesson Summary Video, Urban Planning. This lesson is a solidify understanding task, which takes concepts developed previously and helps you finalize those ideas. The purpose of this lesson is to model with exponentials and solve them algebraically, and then check them graphically. The governments used loans to pay for the project. At the end of the term, a lump sum of $3.3 billion was due. The additional cost is due to the interest on the loans at an annual interest rate of 5%. How many years since origination of the loan are the governments repaying the original loan? Solve the problem algebraically by making an equation and using inverse operations. Check your answer by using the graphical method to solve the problem. So we need to know what we are solving for. So we know that we have borrowed. If we go back and read the original problem up at the top where we're dealing with the light rail, it looks like it was going to cost $1.8 billion. And so the town was going to have to borrow $1.8 billion. And then this has an interest rate of 5%. And so we've got that interest rate. That means it's we're having to add interest on top of it. And so it's 1.05. So we started out with, we borrowed 1.8 billion. It grew at an interest rate of 5%. So we had a starting amount. And then we paid off ever so many years. So X can be our time. Now, what we do know is that in the end, we actually ended up paying back 3.3 billion. So even though we only borrowed 1.8 billion, what we actually ended up paying for it was 3.3 billion. That's how interest works. So we want to know, how long did this actually take to pay off? If we know we started with 1.8 billion, but it ended up costing us 3.3, how long was it earning interest and taking its time to get up to 3.3 billion. So one of the things we want to think about is I can't do the inverse of a function until I just have that function. So I want to get the exponential by itself. And if I'm going to get the exponential by itself, I need to get rid of the 1.8. 1.8 is being multiplied by the exponential. So the inverse of multiplication is division. So I will take and divide both sides of my equation by 1.8. 3.3 divided by 1.8 is 1.83333, one of those lovely repeating decimals. And now I just have my exponential of 1.05 to the x power. And the big thing we learned about inverses is that the inverse of an exponential is a log. So if I want to undo an exponential, I'm going to have to do a log to both sides, specifically the log that has the same base, because I want to undo that base. So if I take log base 105 of both sides, log base 105, then my log and my exponential will undo one another, and I'll just be left with x on this side. And when I take log base 1.05 of 1.8333, I get roughly 12.4 years. Now it asked us to check it graphically. Don't forget that if we're going to graph something, we want to take one side of the equation and graph it. So I want to graph 1.8 times 1.05 to the x power, graph that, and then I want to graph the line y equals 3.3. So here's my exponential, 1.8 times 1.05 to the x, and then here is my straight line, so that's the 3.3, and it looks like they do in fact intersect at 12.4. So 12.4 is how long? 12.4 years is how long it took us to pay off this particular loan. Now, if we were going to explain in detail to a friend how to solve the exponential equation 150 equals 3 to the 2x power. So first, let's think about how we would use technology to solve that. So first, I would graph this side of the equation. So I'm going to graph y equals 150, and then I'm going to graph the other side of the equation. So I'm going to graph y equals 3 times 2 to the x. So first I graphed the left side of the equation, and then I graphed the right side of the equation. And now all I'm doing is I'm going to look for the point of intersection. Because if I graph one side and then graph the other, and I'm looking for where they are equal to each other, because that's what that equal sign means, then I'm looking for the point of intersection, specifically the x-coordinate. The x-coordinate is when they are equal to one another, and the y-coordinate is the value that they both have that makes them equal to one another. So graph the left of the equation, graph the right of the equation, and then look for their point of intersection. Now, if I was going to do this algebraically, the first thing that I want to do is isolate the exponential. I can do that a couple, depending on the problem, but that's always my first goal, exponential. All right. So when we look particularly at this one, if I'm going to get the exponential by itself, for me, that means that I'm going to have to divide both sides by 3. That's what it's going to take to get the exponential by itself. So if I divide both sides by 3, and then the second thing, after I've gotten that exponential by itself, is I want to do the inverse log. So if I have that exponential by itself, I want to do its inverse log. In this particular equation, that's going to be log base 2. And then I also want to make sure I do it to both sides. Because anything I do to one side of the equation, I have to do to the other side of the equation. And then, as always, I do need to finish solving. Sometimes we're lucky and it's just x that was up in the exponent, but sometimes it's not. In this case, it is just x. So I'm actually done at this point. After I do the log of both sides, I have what x is equal to. So we want to remember these steps for solving exponential equations, because that's definitely going to help us as we move forward and try to solve more equations. So let's try and use those steps to help us solve the following equation. 2.56 equals 587 times 0.8 to the x minus 5 power. So step number 1, we said, was going to be to isolate the exponential. So where is the exponential? Let's find it. Here's the exponential. And if I want to isolate it and get it by itself, I need to get rid of the 587. So I want to divide both sides by 587. Now, that is going to be a pretty big decimal. So for the moment, I'm just going to write it like this because we don't want to round yet. Anytime you round in an exponential or a log equation before you get to the very end, you're very likely to get more and more off each time you round. So we're going to try and hold on to all of these decimal places until the very end. So I just want to divide by 587, and that's what I did over here. And so now I just have 0.8 to the x minus 5 power. So then we're ready for our second step, which is to do the inverse log, which in this case is going to be a log of base 0.8. So I want to do log base 0.8 of this number, and I want to do log base 0.8 of this exponential. So the log and the exponential will undo one another, and we're left with x minus 5. And then we have log of base 0.8 of 256 over 587, 2.56. Notice I've still kept this because I do still have to add 5 to it. So I'm not quite ready to round yet because step 3 is to finish solving. And now I think I am ready to do that if I just add 5 to both sides. So now I should be able to just type into my calculator 5 plus log base 0.8 of 2.56 divided by 587, and I do make sure that this is all in parentheses for the log, and I get that x is equal to 29.36. So first we isolated, did the inverse log, and we finished solving whatever was left over. In this case, we had to add 5. Now, if we want to check that answer graphically, it's never a bad idea to check our answer graphically. Let's see if we get 29.36. So if I graph it, you can see that I graphed one side of the equation, the 587, 0.8 to the x minus 5, that's the red line. The blue line is the 2.56, and we can see that they, in fact, intersect at 29.35, which rounds to 29.4. So yes, we did get the correct answer, and we checked our answer graphically.